Good evening, class. Welcome once again to Java, this our penultimate class. So, this is review week. We're going to do review. We're going to do review in two different sections. Number one, we have that practice exam thing, questions similar to the review to test 2. We're going to do that, I think, for the next one, the 2-hour class. For this class, I think what we're going to do is just a big fat review session, similar to what we did for JavaScript. Any objections? No? Good. Because I'm running the show. You have to do what I say anyways. Ha! So Java then. Before we get to it though. Everything cool with assignment 6? Yeah? Everything cool otherwise? Nothing pressing? Any questions? All good, all good, all good? Alright, sounds good. So, Java then. So, due to the superior organization of the course shell for this course, it's fairly obvious what the topics are. You just have to kind of read off what the module titles are. So, without further ado, week 1, well, that's just going to get bothersome if I do it like that. Our first week, we covered input, processing, and output. So I, P, O. There's really not much for us to review there. Hopefully by this point in the course, I don't have to insult you by reviewing print statements with you. However, I won't even say it might have been some time since you did a scan loop, because I believe there was one of those in assignment 5, so you have had consistent practice for that throughout the course. So this one's kind of a non-topic to me. Flow of control, or as it's properly known, control flow. We can review do while loops and switch statements if you like. If anybody has anything in any of these topics that you'd like to review briefly, then please just shout it out. But for now, let's just say do while and switch, which are the less common of those. Object-oriented programming. This one, is basically, week 3 is basically, here's what a class is. Here's how you declare an object. This is what a method is. This is what an instance variable is. Again, hopefully by this point you have a firm grasp of that. I guess how to do a UML diagram is in there as well. I'm not sure that that's a topic which requires explicit review. Arrays. So, while the particular subject of arrays, and the operations that you perform with arrays, these are reasonably elementary and probably shouldn't require review. It might be good to do one array-ish problem as a review of how you handle or approach problems involving data structures. So Review problem? Question mark? Week 6 was test 1. Week 7 was GUI. Again, I'm not sure that this, like, if we're going to review this, we should probably do so in the context of later GUI stuff. So we could say GUI slash events including mouse events. Yeah? Compound subject. All the Java FX stuff. Inheritance, though, that is a topic with a little bit of weight behind it. How do you even spell? Inheritance. There we go. What is it? What does it do? What is it? What arrow does it use? What is the difference between it and association? Very good, very good. Polymorphism. We can cover polymorphism in a couple of different ways. Method overloads / overrides. Subtype polymorphism. And the most recent one that we covered, generics. Type polymorphism proper. Week 10 was test 2, very good, very good. Week 11 was exception handling. Which should have some brief review, at least. Did I miss one? No, I didn't. Polymorphism is kind of like inheritance part 2. It's kind of how it works. Exception handling, mouse events, week 12, array lists. Although once you've covered generics, there's not that much that distinguishes array lists from arrays. So, how does that look for a topic list? Okay. Comprehensive? So, an important thing to understand about the exam, it is cumulative, so it covers material from throughout the course. However, there's a lot that a lot of these topics are kind of built inherently into other ones. A good example, of course, is GUI. We can't really talk about mouse events without having talked about events, without having talked about graphical user interfaces, right? So like everything kind of stacks, right? So I can, like if I give you an exam question that asks you to do something with mouse events, I am essentially testing the entire category all at once. Right? Make sense? So, good. Anything anybody would like to add to this, or do you think that's sufficiently chunky? Any specific subtopics that we might discuss? I can think of 2. Let's throw in there static versus instance. And let's also throw in there, oh, what's the other one? Interfaces. Abstract stuff, which were also fairly important topics that, are not necessarily, represented in the list so far. Sound good? And we can do anything else as we come to it. Yes?
Is final going to be on it at all?
Is what, sorry?
Final? The keyword final?
No. That's something like a const, isn't it? Maybe?
You want to try catch final.
Oh, well, we can talk about it at the end if we have time. Since we are talking about the final. So let's get warmed up then and talk about some of these earlier things. When you are studying, I highly recommend, although it's certainly true that the exam will focus on the back half of the course, as is natural, especially when you have a course with as many midterms as this. It's always useful to go right back to the beginning of the course to refresh yourself on the basics, as that's the material where it's been the longest since the last time you've seen it, right? So, again, I'm not sure that it's useful to talk about print statements and input loops. However, there are a couple of things within control flow which are often neglected or forgotten. We've used while loops. Well, actually, I'm not sure that people use while loops all that much, but we use while loops. We use for loops. We have perhaps even used the for each loop. But does anybody remember what the do while loop does?
It's guaranteed to run at least once.
Yes, it's guaranteed to run at least once. So the structure is as follows. That's a do while loop. So a do while loop is guaranteed to execute the body of the loop once, because it tests the condition after the loop is executed, not before. This can save you a couple of situations where, if you have some front matter to a loop, then the loop, and then the same thing repeated. The do while loop is essentially your remedy against that. If you change it to a do while loop, you can merge these two together, and then, it saves you a little bit of work. But fundamentally, the do while loop does nothing that a normal while loop can't do. Another sort of thing you should become sort of increasingly familiar with is the difference between these two concepts, which are kind of borrowed from regular expressions, the notation. When you see an asterisk or a star, and that means the number of something, you're basically talking about something that's greater than or equal to 0. And with plus, you're talking about something that's strictly greater than 0. So the while loop would fit into this category, while the do while fits into that category. Does that make sense? Right? Because a do while loop, you execute more than 0 times, whereas the regular while loop executes more than -1 times. Make sense? A lot of people don't consider the case when a loop just won't execute at all because the condition is initially false. But it happens. So much for do while loops. Any questions about them? Nice little warm up. So, switch cases then. So switch cases are kind of similar to if-else branched blocks, right? The general structure is this. If we switch on something, x, in structure, this is the same thing as saying, if x is equal to 0, else if x is equal to 1, else if x is equal to 2, else, ah, my goodness, else, trying to go too fast. Right? This is kind of your introductory level understanding of a switch statement. This is like, you know, the understanding of a switch statement, which is, you know, the switch statement is a slightly less complicated way of doing what this this branching if statement is doing, right? Basically the complication that you're removing is this bit where you're equating x to all of these numbers. Now, that's okay. Doesn't quite explain the presence of the break statements, though. Right? Why would break statements be necessary here? Right? Why couldn't we just assume that they're there? First of all, what happens if we leave one out? If x is indeed 1, what do we see? It would do case 1 and then case 2, and then it hits a break statement and it quits. Right? Okay? Fine. So what the switch case is actually is it's a kind of a tamed go-to. Right? So you folks have heard of go-to statements? No? All right, well, go-to. In old programming languages, particularly the further back you go, the more these things show up. In old programming languages, this is what you had, if you go back far enough, instead of loops and if statements. In fact, if you take if statements, loops, any type of control flow you care to mention, every single one of them breaks down into go-to statements. Because go-to statements are actually a command that's native to the CPU itself. That exists in assembly code. If you go back far enough, people programmed everything in assembly code. If you take a look at Atari games, those are programmed in assembly code, right? So essentially, what the go-to here does is it says, all right, well, I have x, go to the case with the label matching x, right? So it just jumps our program's execution pointer to the relevant case, and then it executes as normally. These are labels. They are not executed. They are jump labels. You can actually use gotos in Java, although it's strongly not recommended. You can use gotos in C, again, strongly not recommended. You can do very, very, very bad things with gotos. Probably not so much in Java, but you can do things like jump yourself into the middle of a function you haven't called, for example, which is a terrible, terrible, terrible idea. But basically, some years ago, somewhere about the mid-'80s, well, late '70s, early '80s, the programming community took arms against the goto. Many languages, basically after people had been programming for a few decades and got the experience of it, they discovered that any program containing gotos that aren't in very specific patterns were almost impossible to read. You have a condition, which I'm sure you've heard this term before. It's called spaghetti code, right? So this is what spaghetti code is all about, right? Let's imagine that your code is sort of existing on a line, right? Which, generally speaking, they do, right? And you've got statements that are jumping you to different parts of the program, right? So down here, maybe this one jumps down here or down there. This one can jump back up here or back up there. This one can jump down there. This one can jump down here or maybe back up there. This one can jump down here, down there, or down there. You can see why they start calling it spaghetti code, right? Because it looks like a great big ball of spaghetti. Try to read that. It's almost impossible. So the solution that they came up with was basically, okay, we find that these particular structures of gotos don't cause as many problems as gotos generally. We are going to give them names, and we are going to make them primary parts of the language, and if possible, we are going to force the developers to use them instead of these gotos that they're addicted to. There was a point in the history of computing where the excessive use of gotos and the production of code that was illegible to anybody but you was an indicator of job security. This is not as much the case as it once was. Basically, programming is not as rare a skill as it used to be, and you are replaceable. But you know, if you have if you're like Xerox, right? Like you've got like 2 programmers to like 100 engineers of other types, right? Back in the 80s. So it's like, yeah, no, losing your programmers is a pretty big deal. Not so much of the case anymore. So yeah, gotos are verboten. You cannot use them, you are forbidden. If you use gotos, you will be attacked by velociraptors. But it's still important to kind of understand that all of the control flow that you use fundamentally breaks down into one unit, and that's jumping where the program is being executed from, right? So much for the switch statement. Switch statements are a sort of domesticated version of a goto, just as like if statements and loops, for loops, and those sorts of things. These are, if I were to draw an analogy, these are things like, your Pomeranians or your Shih Tzus or some other breed of dog that's very clearly a breed of dog, right? Whereas switch statements are a little bit closer to their wild form, so maybe they're like a husky or something. Looks quite a bit like a wolf actually, but don't worry, it is tame. Right? Make sense? Enough of switch statements. Enough of switch statements. So, I'm not sure, again, that there's much that's interesting I can say about object-oriented programming that's not already sort of, it should be baked into your genome at this point, how to write a class. So I'm just gonna like elide that topic. However, we should probably talk about arrays. So, arrays then. So arrays are linear data structures. If you want to talk in terms of a more, highly mathematic way of looking at them, an array is a mapping between the natural numbers, including 0. Is 0 a natural number? I'm pretty sure 0 is a natural number. It's a mapping between the natural numbers and other data types, right? So, best way to do this is to do a problem. So let me see if I can think of a problem. Well, we could just do a sorting algorithm, like an easy one. You guys want to do an easy sorting algorithm? Yeah? Sounds good. So we have a couple of, oh man, I should have brought my dice. Gosh darn it. If I had had the foresight. So, the definition of a sorting algorithm then. Basically, let's say you have an array. A disordered array, and the object is to put it in order. Right? Now, sorting algorithms will of course require swap operations. You can kind of see how this is involving a sequence of swaps, right? But of course, we want to do this programmatically. So I will give you a description of a elementary sorting algorithm based just on the name. I can do insertion sort or bubble sort for you. What do you want? How many people for insertion sort? How many people for bubble sort? I think that bubble sort wins by just a little bit, although, how many people have no strong feelings? All right. Well, we'll do bubble sort then because the name is slightly more fun. So, there are lots of very good visualizers for sorting algorithms on the internet, sometimes in their very Wikipedia pages. There we go. So, bubble sort. Let me describe the algorithm, and then you shall see it work on data, and then we will see if you can figure out how it works, but as I'm doing it. So, bubble sort proceeds by examining two adjacent numbers in the list. If they're in the wrong order, it swaps their position. And it examines each of these two all the way down, right? It proceeds through the array by examining 2, then the next two, then the next two, then the next two, then the next two, etc., 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 etc. And then it repeats that, starting at, it repeats that starting, or not going all the way to the end, because after one pass through bubble sort, it's guaranteed that like depending on how you do it, either the largest number is in the correct position or the smallest number is in the correct position. Bubble sort is an awful sorting algorithm. It's got one of the worst time complexities of any sorting algorithm, but it's reasonably easy to understand and therefore is a good introduction to sorting algorithms. So, bubble sort. Let's randomize the data. Randomize the data. And you see how it's examining everything? So the reason this is called bubble sort is that the numbers appear to bubble up through the data as it runs. So you can see this red bar is the one that's being moved. See how we have all of the sorted section growing on this side through every pass? And this is also growing, but not, not stably the way the other one is. So notice that the red bar accumulates, it swaps itself out for the maximum value when it encounters one that's bigger than itself, right? Wow, can I speed this up? Good grief. I don't want to touch it though, But the advantage, one of the advantages is each pass it gets one number quicker to sort it because you don't, you have a guarantee that everything passed here is sorted, so you don't have to re-examine that section, right? Yeah. So as you're watching this, try to think about what the algorithm will look like. But notice how the amount of disorder in the data is decreasing with time, right? And notice how this guy creeps one closer to the correct position every time, right? All the low numbers are kind of bubbling up, right? That's why it's called bubble sort. There you go. By the way, this is a cool website, sortvisualizer.com, because they've got all kinds of good sorts. All kinds of good sorts. Quick sort is also so watch how much faster this one goes. How much faster was that, right? Quick sort earns its name. When all of you are suffering horribly through your data structures and algorithms class in 4th semester, if you ever want to see any of those sorting algorithms you're supposed to be doing done out, this is a good website. Although for learning algorithms, I find the best method is to just put the numbers on little pieces of paper and just manually do it with your hands, right? That's what I recommend. So let's actually program it. So, and maybe we'll even trace it. And don't look it up. It's not impressive to look up bubble sort. So, there we go. So let's have ourselves a Java function. Public int array bubble sort takes an int array x. There we go. And we want to return x at the bottom. So, what do we need?
A for loop.
A for loop is a good start, yes. For int I is equal to 0, I is less than x dot length. Does something. So,
You do I plus plus.
oh, yes, that's true, pardon me. There we go, thank you. So this is the bubble sort algorithm. I examine 2. Are these in the right order?
Yes.
Yes. So I examine the next 2. Are these in the right order?
Yes.
So I examine these 2. Are these in the right order?
No.
No. So I swap them. Then I keep going. Are these in the right order? No. So I swap them. Are these in the right order?
No.
Nope. So I swap them. Are these in the right order? So I swap them. So my array becomes 0, 3, 2, 8, 7, 4, 9. The 9 has been bubbled up to the top. Right? So, somewhere in the middle here, what is the test that I was doing there with my 2 hands? Is this in the right order? How can we express that mathematically?
Using if statement and the index plus 1 also.
So if statement, if x at I is
Is greater than,
x at I plus 1, yada yada yada.
but I think you need another for loop before this statement.
We will. That's why I left some space. But
And you might use J or something other indexing naming.
if I do, I'll change it. So we then do the swap operation.
Yeah.
So recall that swapping requires the use of a temporary variable. You guys remember that? Why? Who can explain to me why swapping requires a temporary variable?
So we don't lose the values
So we don't lose the values, but why would we lose the values?
because we will.
You might overwrite them.
You would overwrite them, yes. So this is a good review of how computer memory works. So if we have, 5 and 10, if we assign 5, if we try to do this, we have to do them in some order. We can't do them both at the same time. So if we first copy 5 in there, we've overwritten the data that we are attempting to overwrite. So, or that we're attempting to swap. So what you do is the following. You have x, y, and a temporary variable. So first you put x here, then you put y there, then you put this here. Swap operation. Right? Sorry, I didn't. 5 goes here, good. Second, 10 goes there. 10 goes there. Next, 5 goes there. And there you have it, a swap operation. So, temporary is equal to x at I. X is equal to, or how much said x and y? X at I is equal to x at I plus 1. X at I plus 1 is equal to 10. So that's kind of the core swap of the algorithm. Pardon me. So now for this this business where when we finish, when we finish execution of the loop, we want to go back to the beginning and do it again. Now a very basic implementation of this ignores the fact that the sorted section exists, and it just re-examines the thing that's already in order. Something like that is very, very easy to do. You don't even need the j variable. All you need is a loop that runs a number of times equal to the length. But if you want to refine it just a little bit, we know that on this first iteration, j will be equal to 0, right? And we have to perform swaps all the way up to length minus 2 as a position. So we can start thinking about how long this inner loop runs for, right? If we run this loop again for j is equal to 1, we will get, in order? Yes? In order?
No.
No? In order?
Yes.
In order?
No.
In order?
No.
And then this is the bit that we don't test. That one's locked in. So this is the last one we do. So you'll see that we are now, if this is position, -1, and this is position -2, and this is position -3, then in fact, what we're looking at is exit length -1 minus j. Right? We would of course be able to get rid of that term if we did something to the comparator there. But that's kind of the normal way you're taught to do it, which I think it's useful to continue thinking about it that way. Make sense? So, this is thinking about arrays, thinking about algorithms, algorithmic thinking. I will reiterate my tips for how to do a problem of this type. Number one, draw the data structure. Take the data structure. It might be an array. I will, in this type of problem, I usually try to give you example data, right? I'll give you a random array that, normally in this type of question, I'll give you like a random array and one that will, is solved or whatever. But anyway, I'll give you some data and you can kind of like draw it out, do the steps like I've done here, right? And do it out in your head. You should do that before you start writing the algorithm. Understand how the data is moving before you start, right? So, good. Again, you can often tell important things like how many nested loops do I need by doing this process, right? If the array that I've given you is like a bit large for the piece of paper that you have to work on rough work with, then pick a smaller one, right? Make a small array, maybe even 4 elements. Do it out that way. Now you don't want to make it too small, right? Like 1 or 2 elements is probably not big enough to demonstrate what you're trying to do. But 4 elements is small enough to be worked out reasonably quickly during a test, and it's it should still demonstrate the properties that you want without too many edge cases. So draw out your data. Once you've done that, think about what the structure of the code should be. You can even do that out in pseudocode. Loop, loop, if statement. Right? Then, once you have a plan, go after the actual Java implementation. Make sense? Any questions? Good. So, I think that'll about do it for arrays. I'm not even quite exactly sure that it's useful to do GUI, during a review session, because it's like, here, memorize this, be aware of what the buttons do and how to work with the data. There are a couple of points, a couple of common pitfalls which you should be aware of when working with the JavaFX template, but it's all very specific to the JavaFX template, right? Things like don't reinitialize any object references that you have initialized outside of the start method, right? If you redeclare them by providing their data type, they will be declared as local to the start method, and they won't work. Probably a lot of you have already experienced this inside of your assignments. It's a very common sort of error. Aside from that, the actual programming work inside of the event methods and that sort of thing tends towards the trivial, right? It tends towards the trivial because, once you've got the event set up, there's really you're back in Java land, like normal Java land, and it's easier to test that kind of thing on normal Java programs. Does that make sense? Be aware of how to, that you can relocate things and set their width and height and that sort of thing, right? That you can set their colors. But once again, you will be given a reference sheet that includes many of the methods that are necessary for JavaFX. So, should be easy marks. So, now perhaps we pass into some of the chunkier subjects. Anybody have any idea what they'd like to do first? Any requests? No? Everybody's kind of just content to listen to me talk, huh?
Yeah, basically.
Yeah. Well, you know, if you let me talk long enough, maybe I'll give you the answers to the exam, right? It's been known to happen. So, there we go. Inheritance. We must understand inheritance from a conceptual level. So, we must distinguish it from association. So, what is association in Java?
Has a relationship.
Has a relationship. Yes? Anybody care to contribute to the solution? What is association? If I were to take Java code and create an association, what would I write? I have a class. I want to create an association link with another class. Yeah?
They would have like an object of the other class?
Yes. So inside of its declared instance variables, you would have an object reference to an object of the type of the class you were associating with that class. So for example, if I had class A, public class A, like that, and public class B, if I wanted to say A has a B, I would say public or possibly private B object. That creates an association link. You have done this many, many times. What if the arity of the relationship is unbounded? What do we use? An array list, yes. Array list, you would have public array list taking an object of type B, B's.
I have a question.
Yes.
Can it also be an array though? Or is it the asterisk that tells you it has to be an array list? You don't know the size?
Yeah.
Yeah, the issue is that you don't know the size, right? For something like that, where you know the size and the size is bounded, in that case, we have a size for the array that we can declare. The beauty of the array list is that you don't need a size. So, asterisk and also plus, remember that old duality? 0 or more, or 1 or more? Both of these, optimally, are array lists. Make sense? Any questions? Good. So that's association. What if A is inheriting B? Public class A extends B. So what does it mean for one class to inherit another?
in this case, A is a B, so it contains all of the methods and variables contained in B. So it might have its own, like a subclass of variables or methods.
Yes. So there are a couple of ways that you can think about it. I find a useful way of thinking about it is kind of set theory-ish. So if you imagine the set of all things contained in B, right? A is all of the things in B plus some extra things as well. And in fact, some parts of A might overlap some parts of B because A has the ability to override method definitions provided by B. Although I would say that the dotted line is still correct, because even if you're overriding a method, you can still access it. Right? How can you still access it? Oh, somebody said it.
You're using super.
Using super. That's right. So if I have, toString is the most typical example. If I'm defining a toString class for A, I can use within that super.toString, which gives me the definition contained in B. I can use that as part of my definition for A to minimize redundancy. Make sense? Good. So inheritance is an is-a relationship. You should be thinking in terms of more and less specific categories. Right? So, you can think of many, many examples as human beings think primarily in categories. For example, bicycle is a category which describes things. Mountain bicycle, mountain bike, that is a particular type of bicycle. Electric bike is a bicycle. Mountain bikes and electric bikes are very much not the same sort of thing, right? But they both exist in the same category. In Java, both inherit from the same class. When a class inherits from another class, there are a few pieces of terminology that we use to describe that relationship. B is the base class, A is the derived class, B is the parent class, A is the child class, B is the superclass, A is the subclass. Now this is a little bit confusing because if you think in terms of set theory, A is a superset of B, and yet B is the superclass of A. It's a little bit bass-ackwards, as it were. But that's okay. That's okay. Make sense? Any questions about inheritance? I will say it now, most people don't use it properly. So you would think that being such an old, basically being the entire point of object-oriented programming means that people would use it correctly. But unfortunately, even from many examples within the course notes themselves, people seem to get this idea that, if you take some kind of trivial property that's different between two classes, you put that in the class name and have them inherit from a common type, and that means suddenly that it's inheritance, right? Which is, yucky. It's bad. It's gross. It's bad design. Like, for example, in our mountain bike, electric bike example, if the only difference between electric bikes and mountain bikes was, for example, tire width, if that was the entire thing, then there's no reason to have those two different classes. You could just have one variable, tire width, that varies among objects of the common class, right? What these things are really for, what inheritance is really for, is when the methods are different between the two different classes. So an electric bike would implement methods that a mountain bike would not. Recharge, for instance, is something that makes sense to do to an electric bike, but certainly not to a mountain bike. Right? You kind of see where I'm going with that, right? So I'm trying to think of something a mountain bike has that an electric bike doesn't, but I can only think of like good suspension. Oh yeah, gears. Don't electric bikes have like gear assemblies? No? Ah, well there you go. All right, so the mountain bike has gear assemblies, right, which allow you to change speed. 15 speed, 20 speed, mountain bike, etc. Electric bike, not so much. So gear shift would be, on a bike. It's not like that. You guys know what I mean. What is it? It's a little thing on the top like that, right? Gear shift on a mountain bike is a method that electric bikes wouldn't even have, right? So really, the situation that you're using inheritance to do a better job of programming, if you ever find yourself programming a variable is mountain bike, and then you're allowing or disallowing methods based on whether is mountain bike is true, that's a situation that you should use inheritance instead. Does that make sense? Good. Any questions? Okay. Perhaps enough said about inheritance. So, shall we talk about static versus instance then? Static versus instance. So, this is kind of, again, one that's poorly understood generally. Like, there's a reason that this class exists and is what it is. It's because a lot of these object-oriented ideas are generally poorly understood, particularly by people who have had no formal education in it. So, who can tell me what a static variable is? What's the difference between that and an instance variable?
The static variable is created once, whereas an instance variable is created whenever an instance happens. Okay,
so a static variable is created once. Instance variables, you get one for every instance. Instance of the class in the terms of objects, right? So, yes?
There is one thing also, that static variables is shared among all instances of a class.
Static variables are shared among all instances of a class. Yes, and actually possibly even further than that, right? It depends on whether it's public or private, right? So, the best way I have found of explaining static is this. When you have, did that thing just beep? No, it didn't, okay. If my camera beeps, it means it's like out of memory or something. So, when you declare something static, you are attaching it to the class rather than to any specific object. Right? You're attaching it to the class rather than the object. So, for example, a kind of a typical example of static is keeping track of how many objects from this class have been instantiated. Right? That's kind of like, that's often useful to know, right? Not to pull video games into it or anything, but let's imagine that you were programming something like Space Invaders, right? Would it not be useful to be able to say, you know, enemies dot population equals 0, you win. Or next level, right? That would be useful. So, public class enemy, right? You know, assuming all the rest of the instance variables, etc., are all done up, let's make a public static integer population. So one of the things, we'll get into it. So, constructor. Well, let's make this private. So we can set this thing in the constructor. When we create a new enemy, and you can imagine like, it's the type of enemy, and maybe these are like, you know, like slime enemies where you beat one and then it splits into 3 slimes, right? 3 smaller slimes. When you call the constructor to the class, the constructor should increase the population, right? It's like, oh, I have created a new object, I should update population so that that's the case. So, public enemy dot dot dot, sure, right? Dot dot dot, somewhere in there, population plus plus. We don't really talk about it very much, but it is also possible to write destructors in Java. You know, a lot of the time there's no call for them because when you know, in Java, what passes for memory management is often just like intentionally losing a reference to a declared object and relying on the garbage collector to eventually come and hoover up the broken reference and free the memory. That's kind of how it generally gets used. But it is actually possible to do proper memory management in Java and release memory yourself when you're finished with it. So there is such a thing as a destructor, and we can write it in such a way that the enemy population is decreased when the object is destroyed. You'll just have to take my word on that. We didn't, I don't think, cover it in class, so obviously it won't be on the exam. So just that much, though, means that elsewhere in the code, elsewhere in other classes, we can say things like if enemy dot population is equal to 0, next level. Right? Does that make sense? So when we have static variables, we can call them, we can invoke them from the class name itself. We can also go through object names. we can go through object names, or we can go through class names, but you can't just go through the class name with an instance variable, right? And there's a very good reason for that, right? If, let's say, just for example, you were trying to get, I don't know, say position. Position is an instance variable for an enemy. Let's say you were trying to read a particular enemy's position using enemy.position. What is the problem you run into? Say you have 50 enemies instantiated, right? You have 50 enemies instantiated, and you're trying to read the position of one of them from the class, right? What's the problem?
Don't know which one you're gonna get.
Precisely. Be the first one. See, Java would just refuse to do it, right? The problem is that it's ambiguous, right? The question that begs, which one, right? That's not a question that Java can answer, right? It doesn't know which enemy's position you want if all you've given it is enemy. Now, if you want to keep a static record of the position of every enemy, that's a thing you can do. It might even be useful to have, for example, a static array containing a reference to every instantiated enemy. That might be a useful thing to have. You'd never lose them, but you'd also never, they'd never get garbage collected either, right? But just the class, without that set up, it's still like, okay, which one? Which enemy are you talking about? It's like, go back, find the reference to the enemy you want me to look up, and I will look it up. But until you do that, I'm not interested. No way, Jose. So, this is also the reason that you can't call instance methods from the class itself. Instance methods, most of the time, like you can think of even getters and setters, right? If you're calling a getter from, like this, you run into right smack dab face first into the same problem, right? You want me to call the getter for which object? I don't know, you didn't say, so you can't do that, actually. I am Java, and I say that you can't do things I don't like. So that's the reason. But static information can be used anywhere, from within any method and from within any class. Well, so long as it's public anyway. So, you might be saying to yourself, okay, well, what if I want to lock down position so that things can't or lock down population so that random classes can't modify the population in ways that I don't want? Like clearly that's, clearly that there shouldn't be write access all over the place for that, right? So we should have a getter. Well, in that case, you would have a public static int get population. Right? So you can have static methods. That's like the 4th time I've done that. Oh my goodness. Ugh. So, you can have static methods. Static methods work on static data. Static methods do not work on instance data. Why? Same problem. It's the same reason. If it's ridiculous to try to pull out an individual enemy's position here using just a reference to the class, it is equally ridiculous to get a static method which is attached to the class to know about any particular instance. It doesn't know it, it can't do it, right? So static methods can't re-instance variables, which I'm sure every single one of you has experienced, because what's the most famous static method? Main, absolutely. And if you have been playing with Java, as I hope you have been, one of the things you probably tried doing was making your variables inside of main their class variables rather than local to main. And as soon as you tried to do so, you ran face first, you stepped on the rake, and the rake said that was not declared static, right? You were trying to do this thing. You were trying to read instance information from a static context, which is not allowed. Does that make sense? Any questions about static? Static. All right, cool. I know that the focus today has been more conceptual. That's okay. I'm doing that because we have our other class today to kind of dive more into code, right? So this is kind of concept review more so than, more than code practice. Any questions? Time is currently around 6:20, so I think it's about time we have our break. Any objections? No? Okay. So let us resume class at, I guess that would be 6:33. All right, 6:33. Can we please resume class at that time? Very good.
Sure.
Let me just pause my camera. All right. So, all right. So, polymorphism. Where's my marker? There it is. So, polymorphism in this class had three main variants. We talked about method polymorphism, overloading and overriding. We talked about type polymorphism, subtype polymorphism. So, if something is, if you have a derived class that's derived from a base class, the derived class will satisfy a type checker requirement for the superclass. We'll get into it. And finally, we had generics, which we covered oh so briefly, but we can talk about them briefly again. So, overloading. Let's talk about overloading. What does it mean for two methods to be overloaded? Someone other than you. You've answered like most of them. Come on, somebody else.
Same method name, different parameters.
Same method name, different parameters, yes. So, I'm going to give you a mental model for this, which perhaps is a little bit different from what you would have gotten in the first half. Maybe this will be helpful. Another helpful way of seeing it. So, you should think in terms of a calculated interface, right? In the same way that in CSS, you think in terms of, okay, here are my set of conflicting CSS rules. What is my calculated style? In that way, you have something similar with Java. It calculates what the interface of a class actually is. So let's imagine that we have some classes. I immediately launch into combining this with overriding, but that's okay. So let's just talk here for a moment, all right? So in class A, we have the method foo, which could take an integer or it could take a boolean. The thing that makes it polymorphism is the fact that the implementation of this method is selected based on what the input parameters are at the time of the call. Now, of course, this is Java. The type of the variables that you plug in is known. It has to be declared up front. So the preprocessor can actually calculate whether or not you're using polymorphism correctly before it even runs the program. But that's neither here nor there. So if we think in terms of an interface, right? We have foo taking an int, and we have foo taking a bool. This applies to public, by the way. Public, there we go. So call it with a boolean, get that one. Call it with an integer, get that one. So it goes. So now let's throw in overriding. So if a class which is a subclass of this class, also has definitions for foo. Let's say it has foo taking bool and foo taking double. When the interface for this class is calculated, you build it up in layers, right? You start off, this is the basic interface, here you go, basic interface. Now let's layer on this stuff. If we sort of indicate what copy of these we are talking about with numbers, this starts off, in fact that might be a thing to do universally, let's just say A. We add this method, foo taking boolean. Oh, we already have one, so override, insert the version coming from class B. Take this, do we have anything like it? Nope, nope, add it. Make sense? So far so good? Another thing that's important is to realize that int bool and bool int are actually two different entries in this table, right? It's not only the number and type of the parameters that matters, it's also the order. Does that make sense?
Yeah, I got that wrong on the test.
So you'll remember it this time, right? Yeah,
Can you repeat that?
certainly. When you're doing method overloading or overriding, int bool and bool int are overloaded, not overwritten, assuming they're in a superclass and a subclass. These are not conflicting definitions. It's not only the number of arguments and the type of the number of the types of each arguments, right? We've got one integer and one bool in both cases. It's also the ordering that matters, right? So int string 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 is different from string 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 int, right? You can't just say two ints, a double, and a boolean. You have to say what order. because double double int bool is different from double int double bool, etc. Does this make Java needlessly complicated? Possibly. But, you know, honestly, in practical terms, should you really even be doing this much overloading, except for like constructors? Probably not. There's a reason that we, in the notes and in the course, we've dealt with overloading, primarily for the purpose of constructors, right? It's not the sort of thing that you would normally do on regular methods. Overriding, though, that's certainly something you would do on regular methods. Make sense? Anytime a method needs to be made more specific with the more specific information included in the subclass, that's when you override it. Two strings being the obvious and correct example. Make sense? Any questions? Very good. So we'll consider that discussed. Nobody has any questions? We certainly have time for questions if anybody has any questions. Yes?
How much of generics will be in the final? Isn't much of it.
Not really any, actually.
Because you already wrote the test or the final?
So without revealing too much, yes, I have already written the test, and the test has actually already been to the printers, which means that basically I have this week to take extra vacation. No, I've got lots of marking to do, and I'm working my way through the actually surprisingly minor pile of marking that I've got. Like if anybody has been paying attention, the grades for assignment 4 for JavaScript went out in the early afternoon or slightly before noon or something like that. I already forgot. Tomorrow you will have your Java assignment graded, unless something very strange happens. So yes.
Yeah, so then you answer the question, there isn't much generic on the final.
There's not really much to do with generics on the final, no. However, it's still a very useful, it's still a very useful thing to know about Java, especially if you want to consider yourself a professional Java programmer. It's kind of essential knowledge, but there's lots of stuff in Java that we didn't get to in this course, right? It's like, it's a big language with a lot of stuff in it. But that's okay. When you guys do, I think it's called Object-Oriented Systems in 3rd semester, you're going to be doing C#, and you should basically kind of think of that as like this class part 2, because it will continue to extend a lot of this type of material except into C#. C#, by the way, is sometimes colloquially known as Microsoft Java. It's kind of funny because it has nothing to do with C++, really. It's a Java clone, not a C++ clone in any way, shape, or form. One wonders why they called it C#. Do you guys know where the name comes from, C#? Because it's an unoriginal joke after an original joke, right? So you have C. C is actually also a successor language to a language called B. So B plus BCPL became C. All right. C begat C++, which makes sense because what's that? That's the increment operator, right? So C++ is C incremented. Very good, very funny, huh? Right? Then C begat C#, except it didn't really because it's way more Java based than it is C++ based. But let me do something for you right here. Get the joke? So C# thinks it is C+++++, and they take the pluses and they smush them together into an octothorpe, and that is where the name comes from. Yes.
Didn't they actually try to make J++, but they got sued pretty heavily by Sun, I think?
Yeah, I think so. Yeah, I'm not sure about the details, but yeah, J or J++ or something like that. Yeah, because Java is trademarked and stuff. Yeah, whereas but like C# is called C# for the same reason that JavaScript is called JavaScript, right? It's like it doesn't really have anything to do with the language, right? It's just marketing, really.
Do we learn C at all throughout this course?
Unfortunately not, I'm sorry. I wish I could teach you C, but them's the breaks. They stopped teaching C in this department a long time ago.
Is it not sought after anymore?
Well, you can still get employment as a C programmer, but you have to be a pretty high skill programmer to get employed C programming. The domains of application are operating systems stuff. So if you want to get right down into the guts of operating systems, C is still your language, although it's being superseded by Rust. That's a thing that's happening, at least in Linux world. And as we know, Linux world is where all of the true programming goes on. Embedded systems and phones are also places that you'll still find C in the wild. You guys know what embedded systems are?
Like smart thermostats?
That's one example, yes, but believe it or not, this thing, that's an embedded system. Anything that is electronic and has buttons is an embedded system. Most of the time these things have microcontrollers. The microcontrollers are little tiny chips that run C programs, and that's how these things work. Like, all this thing really does is like send a verification code to my car, right? Which, by the way, is extremely easy to crack. Not because my car is particularly easy to crack, but just because that's a terrible way of doing that, because it means that anybody in range who guesses the right radio frequency gets into your car. Stupid. Don't trust Wi-Fi. Don't trust wireless communication. It's a miracle it works in the first place. Your watch is an embedded system. Your watch is a more advanced embedded system if it's something like a Fitbit. The average automobile, if you have one that's like if you have something like a Honda Civic, it'll have over 100 computers in it, right? And when they say this thing has over 100 computers in it, what they mean is they have over 100 microcontrollers in it that are all running C programs. So yes, C still gets used. The other thing is these stupid things. So one of the most important things about these little pieces of, these little, what are they called in Minecraft? The nether portal, right there. That's what this thing is. Battery life is kind of important. right? Like, I'm sure we've all been there where we've downloaded somebody's program and it's like, doo, I'm going to play 15 minutes of, Flappy Angry Bird or something. And then you're like, what? I just lost 40% of my battery. What? I am uninstalling you battery consumer. So basically what that is the program taking more resources than it needs to, right? How do you get a program to use fewer resources? The answer universally is to optimize it in a lower level language, right? Higher level languages will use more computation to do the same work than lower level languages, period. That is a law of nature, right? C is the lowest level language that's not assembly language, right? So it's a natural choice for people who can't be bothered learning assembly, which should be everybody. But, yeah, because assembly is, if you think C is bad, try programming in assembly. But if you, believe it or not, there is actually a thriving market for assembly code programmers to program these stupid things, to get the optimizations down so that, have you ever noticed that, YouTube, you can watch a YouTube video, almost forever, but if you watch a video on, pretty much any other app that does video, it's a serious power draw, right? You notice that? That's because YouTube has been optimized by Google. Whereas, whatever other video thing you have, I don't know, maybe Twitter videos. I've never actually watched Twitter videos, but I think they probably would drain battery pretty nicely. Because, it doesn't act like Twitter in concept didn't really require any programming expertise to pull off, whereas something like YouTube does. But anyway, that's why you can have 11 billion things that claim to be Twitter overnight, because Twitter is so simple, you can just replicate its functionality like that. But anyway, assembly code, there's still work for assembly programmers, absolutely, particularly programming ARM assembly, ARM processors. But unfortunately, it's a bit too rare a skill for us to teach at a college. And the college has to focus on practical languages of employment rather than academic languages. But yeah. If you want my advice about what language to learn, a language that's aside from TypeScript, which everybody should learn TypeScript, but because why wouldn't you want to do JavaScript with type-safe types? Think about learning Rust, because it's kind of in a phase right now where it's starting to gain momentum. Did you guys know that they're adopting Rust for pieces of the Linux kernel now? Did you guys hear that? Do you guys know what the Linux kernel is? All right. So Linux, right? The Linux kernel is it's the beating heart of the operating system, right? You have 11 gazillion different flavors of Linux, but most of them will use the Linux kernel, right? So if they're starting to use Rust there, then they have tested it, and the claims it makes about being as fast as C are true, because they will not sacrifice speed, right? And they see some advantage in it. The Linux kernel has been C up to the introduction of Rust. right? So Rust is the new systems language that's up and coming. Unfortunately, it's also quite a difficult language. It's probably harder, as hard or harder than C++. So, but once again, my career advice, as always, is you should learn difficult and rare skills because you know, everybody and their monkey can pick up a little bit of client-side JavaScript, right? Or even worse, like if your coding skill goes no further than like HTML, CSS, there's actually nothing distinguishing you from an artsy. You know, like artsies use HTML. And if you're a programmer, you should be able to program things that artsies can't program. So, not that I have anything against artsies, but you know, they don't like math, right? That's why they go into art. Yeah, learn rare skills, learn difficult languages, because that's a path to secure employment. Unfortunately, just because of like the nature of a college program, we can only give you common languages, right? Because those are like the ones with the biggest base of employers, right? Which is what we have to serve. But hopefully, once you have acquired the skills here, you can use them as a stepping stone into a more rare, more difficult language. Like it's also true that becoming highly skilled in any of the languages we're giving you an introduction to is a path to the same thing, right? Like after a certain point, all employers will recognize like the value in a highly skilled programmer, because a highly skilled programmer literally does like 10 times the amount of work that, you know, moderate or unskilled programmers can do, right? Like a highly skilled programmer thinks about things like, ooh, I did that a little bit ahead of schedule. Maybe I can use this extra time to automate some of my processes so that I can do the next batch of things even faster and have more time to automate more things. Those are the types of things that like programmers at that level kind of think about, right? And that kind of saturating into the industry is kind of where DevOps comes from. But anyway, all right, let's talk about polymorphism a bit more. Subtype polymorphism. So let's imagine that we have type A, type B, maybe even a type C. B is an A, C is an A, right? These two are subtypes of A. If I have a declared, I'm declaring an object of type A, I can supply that variable with either a B or a C, as well as an A. The reason that this works is that because B is a superset of the stuff inside of A, it's guaranteed to have all of the things that A has, right? So, you know, for example, going back to our long familiar geometric object example, if A has a draw method, B and C are both guaranteed to have a draw method. At worst, they inherit the definition and leave it alone. At best, they conform it to whatever type of object they are, right? Circle draws a circle, rectangle draws a rectangle, right? But you're guaranteed to have at least this much, right? You're guaranteed to have at least a amount of stuff. Does that make sense? So, like, in order to think about all of this, all of these rules, these strange rules in Java, like, the framework in which to understand them is always like, Java is trying to make guarantees to itself, right? It's trying to make it so you can never get in X situation, right? So in this case, you know, B has all of the stuff A has, so the type checker is satisfied with that. Does that make sense? The reverse cannot be the case. We cannot have a declared B object being satisfied by a declared instance of A. I normally have a rule where I try not to put things that are wrong on the board, but you know, it's bad policy because like people will remember the wrong, but they won't remember that it was wrong. You know, this is wrong. This doesn't work. The reason that it doesn't work, let's imagine that the type checker thinks, okay, B has some, like B has a method foo, right? Our ever-present foo method. A does not have a definition for foo, right? The type checker thinks this thing is a B. Therefore, it thinks this thing has foo. If I declare it this way, it does not. So I could mistakenly call object.foo. The type checker, which thinks it's a B, would say, yeah, that's fine. I'm okay with that. But then you would get a strange compiler error, method not found, right? So, because this thing doesn't have a foo method, it's been declared A, right? So, that's why it's not reversible. Reversible because you can get into situations where you're looking for methods that don't exist, right? Now, going back to our previous example here, if we have this line and we try to call object.foo, what sort of error do we get?
Is it because you didn't cast it?
Yes, it's because I didn't cast it. Well, casting it is the solution, but what is it the solution to? Is my question.
Declared versus actual, like, not matching, like declared type?
Yes.
I don't know what the actual error is.
Right. So I'm calling foo on this object. This object is a B, so it has a foo. But it's been typed as A. The type checker looks at A and it says, there's no foo here. What are you doing calling foo? There's no foo here. There's no foo here. Okay, that's wrong. Sorry, you need to redo that. That's what the type checker says, right? So the type checker is looking at this thing, right? Foo, object.foo doesn't exist. And you might be saying to yourself, but it's a B. B's do have foo. What gives type checker? Type checker says, that's not a B, that's an A. And then you say, no, it's a B. And the type checker says, oh, it's a B. Okay, well, if it's a B, then okay, then foo is correct. Yes, absolutely. Why didn't you say that before? Right? And that's the conversation that you're having with the type checker.
So is that a compilation error then?
Yes. It's a compilation error is a large category of error, including parsing error, syntax error, type checking error, and other sorts of errors like file not found, checked exceptions in Java. So this is a type check error, but it is also a compiler error, yes. Sorry that was unnecessarily specific. That's kind of my job, though, is to be unnecessarily specific. So, this is a cast. This is what a cast looks like on an object when you're calling a method. You must bind the cast to the object with higher priority than the method call, because if you just do this, the default order of execution is that. Well, actually, technically, that. Right? That's the default order of execution. So it will still try to execute foo over an object that is A, so that is a type check error, and then post fact try to interpret whatever the output of foo is as a B. Right? So you have to do it first. And that's how you do it first. Does that make sense? So, you might be saying to yourself, this sounds too easy. And I'm like, yes, yes it is. What happens if that's a C? C is also, well, okay. Let's assume this also has a foo. Although, honestly, if you have these two classes, and these are the only two classes, and they both have foo, it should be every bloody time. It should be in the super class, but let's just leave that aside for the time being. So basically, if this is a declared thing of type C, right, and it's like, oh, well, you know, this is our fix, B object.foo. It'll say, the compiler will say, oh, that's an object of type B? Oh, well, okay then, that has foo. Everything's fine. All good. Don't worry about it. Yeah, okay, it makes sense. So saith the type checker, so saith Javac, the Java compiler. But you must satisfy two programs, not only Javac, but Java itself, Java the runtime environment. When you try to cast an object of type C as an object of type B, it will crash. At runtime, not at compile time. Right? You have tricked the type checker. You have bamboozled it. You have tricked it into thinking that your program is not hot garbage, but your program is still hot garbage.
I have a question. If there's like a class D that is a child of like B or C, could you create like A object equals new D?
Like that?
Yeah.
Like that?
Yeah.
Yes. Yep, because, you know, this is still a subtype of that. This is still obligated to have everything that this has in it. It just also has everything this has in it as well. So yes.
Okay, thanks.
Good question, good question. So, basically you need to test to see what the thing is before you cast it. And the way that you do that in Java is, for example, object is instance, or maybe it's just instance of. there's a keyword, instance of, I think, B. You slap that in an if statement, and then you can throw that in there, and you can deal with the consequences otherwise. Make sense? So you test it to see if it's the thing you think it is before you call the method. Make sense? Any other questions? Okay. So much for subtype polymorphism. Talked about static resistance. I think the next thing to talk about in logical sequence is abstraction. Right? So, who can tell me what it means for a class to be abstract?
Another constructor.
It doesn't have a constructor, that's true.
Yeah, it can never be made, but it declares that like anything that would have it needs to have certain variables or methods.
Yes.
Isn't it like they can't write to, but they can read from? Is that?
So the abstract keyword disables your ability to create an object from a class. That's like, if you know nothing else about abstract classes, remember that, right? Abstract classes, you cannot make objects from them. Now, this makes sense in terms of metaphysical analogy. If you think about categories, right? And I know this is getting pretty philosophical, but this is how Java works. Java is a thinking person's language. So let's think about categories, right? If I have an apple, well, I did fruit during class. Let's do a different one. Let's say I have a hammer, right? Let's say I have a wrench, and let's say I have a pair of pliers. What do all of these things have in common? They have handles, sure.
They're like tools.
Thank you, yes, they're all tools. Although, you're kind of jumping a little ahead. That would be like has handle would be an interface, right? Actually, the handle is the interface to the tool, if you think about it. So all of those those three things are tools: hammer, wrench, pliers, right? Is there such a thing as a tool? Right? Only in so far as there's some other specific object which is a tool. Right? So, you can't just go to the hardware store and if you went to the hardware store and you said, excuse me, sir, I would like to purchase a tool, please. And he would say something like, well, what did you have in mind, right? That's not enough information for him to get a tool and sell it to you. You need to know what tool. So, tool is an abstract category, right? Within the regions of human thought, there is no such thing as a tool in terms of physical manifestation. Now, does that mean that there's no such thing as a tool, period? Obviously not. Tool is a concept, right? This is kind of like, not to get too philosophical, but this is a problem with materialist philosophy, is like, they imagine that like the state of existence or reality is only conferred on the final category of things, categories of things that are like physically instantiatable objects, but that is to ignore like basically everything that's not, that you can't reach out and slap in the face, you know, which is most of human thought, right? Like the concept of thought is not a physical thing, right? If anything, thought is like a meta-phenomenon arising from the human brain, which is like a thing that a materialist would say, but even insofar as that, you know, like the materialist has already kind of half admitted that materialism is stupid because they've already admitted the existence of metaphysical phenomenon by admitting the existence of thought itself. So, you know, because like what is thought? It clearly exists, right? Obviously thought exists, but like you can't trap it in a jar, right? It's a meta-phenomenon. So, you know, anybody who says that metaphysics is all about like ghosts and extraterrestrials and stuff like that is confusing metaphysics with paranormal. Those are two different things. Metaphysics is very, like, it exists and it's philosophical and it's like, you know, it's very well grounded, and no aliens are involved necessarily. But anyway, so abstraction in Java means that the class itself, remember that classes are supposed to be analogs for categories in real life, right? That's why it's called object-oriented, because we are orienting towards objects and categories of objects. Object-oriented programming is an attempt at an implementation of metaphysics in a programming language, if you didn't know that already. So, abstract means you can't create an object from it directly. You need, just like our hypothetical man at the hardware store, by the way, he's also a metaphysical abstraction. Our metaphysical abstraction of a man at the hardware store needs more information about the tool in order to allow you to purchase a tool. Java requires more information about the object you wish to instantiate than an abstract class. So, okay, all right, we get that at that point. But why? Why can't, like, there must be some physical reason that you can't implement an abstract class. And that, my friends, is the abstract method. So abstract classes are also permitted to have abstract methods. What is an abstract method?
It's a method that must be implemented by its child.
Yes.
And it's a way to get around the limit of only being able to inherit from one parent.
That's an interface. We're not quite there yet.
Okay.
Yes. So, you know, if I were studying for a test, I would definitely write down the difference between abstract classes and interfaces. So, the abstract method, what is it missing?
The body.
The body, that's right. Abstract methods have no bodies. They are just the first line. Therefore, they can't be called. There's nothing to call. So what's the point of a method you can't call? It exists to be overridden. Trying to think of a joke trying to think of a joke. It's like the new version of Civilization, the Civilization 7. It exists to be overridden by all of the DLC that they're going to hawk after things released. So, abstract methods, the only purpose of them is that they must be overridden by any subclasses. Because abstract methods, you can't make objects from them, there's no point to them all by themselves, right? They exist for the purpose of being inherited from. So if you're not inheriting from them, you're not using them correctly, right? So anything that inherits from an abstract class picks up abstract methods and is required to implement them. That is the purpose of the abstract method. It is a way of obligating your children to do what you want, which is every parent's dream. Right? So, that was a much better joke. So, the abstract method must be overridden because it needs a body in order to be run. The type checker you can't just leave it abstract. The type checker requires that the inheriting class provides a definition for it. That's what the purpose of the abstract method is in the first place. Now, abstract classes are still permitted to have instance variables, and they're still permitted to have instance methods and static methods. They can just have this additional type of method as well, right? But they can have all the rest of the stuff too. But sometimes you think to yourself, I want to obligate people to do things. I want to control and constrain the way in which things are done. I want power, raw, unlimited power to get people to do what I want. So, there is a thing called an interface. An interface essentially boils down to a collection of abstract methods. Insofar as you can't create an object from an abstract class, you certainly can't create one from an interface. So, when you want to collect up a collection of like methods that all work on the same sorts of data, that's something like that. You drop those into an interface. None of the methods have any bodies, right? And because none of the methods have any bodies, Java can inherit from, or Java classes can inherit from as many of those things as you like. That's the thing that liberates you from. And I think one of you guys said something like that. So the purpose of the interface is to create multiple inheritance. But the thing that you're inheriting is sort of, it's not producing, okay. I probably did this up on the board at one point, but let's consider the concept of multiple inheritance, right? That's the weirdest square I've ever done. Ugh, there we go. All right. So let's say that both B and C have foo. All right? Let's say you call a.foo. Which foo? Ambiguous. Problem. Right? But only if these things have bodies. The bodies will be in conflict. But if it's just the concept of a foo, right? if both of these are obligation, or even, actually, if even one of these is an obligation to have a foo rather than a foo itself, you can say, okay, according to B, I need to implement foo. Okay, according to C, I need to implement foo. I implement foo. I satisfy this one, I satisfy that one. Right? There's no actual conflict unless these things have bodies and can be executed. Right? Because they can't be executed, there's no conflict, so you can multiply inherit from interfaces, even at the same time as you're extending some other class. Does that make sense? Any questions?
Yeah, do interfaces have special arrows or special looks
Oh.
for italicized something?
Yes. So interfaces have dotted inheritance arrows. That's the visual difference, yes. They'll also generally have like interface written across them so that it's super, super duper obvious that it's an interface. One tricky thing. Tricky thing about UML diagrams. How are static members represented in UML diagrams? Underlining. Underlining is obvious. How are abstract members and abstract classes represented? Italics. Significantly less obvious. So when you are looking at UML diagrams on any sort of, I don't know, hypothetical, is there some kind of test coming up or something like that? If there was a test coming up and you were required on that test to look at UML diagrams, I would be very careful to make sure that you're picking out where things are italicized and where they are not. Look for italicization. Okay? Sound good? Okay. There, I just got you 3 points on the exam. Don't say I didn't do nothing for you. So much for abstract. Any questions? Any further questions about abstract? And just remember the most important thing about our discussion of abstract stuff. Materialist philosophy is internally inconsistent and rife with internal contradictions. There we go. So, we've kind of already talked about array lists a bit. There's not much to distinguish them, really, from arrays. You kind of, like the example that we did with bubble sort, we could easily have done with an array list. All we would have to do is substitute the types, right? Except that, it's possible, it's conceivable that the array list might have a built-in swap method, which you would use instead of doing it manually, right? And like, it uses a get and a set method rather than direct access using square braces. But aside from that, in terms of everyday usage, aside from that, there's also the fact that it probably has a sort method, right? But let me tell you folks, if you're here or in data structures and algorithms, you are told, write me a sorting algorithm, and you just say, return a dot sort, well, you'll get as many marks as that solution took in effort, right? Yeah, there's not really much to say about array lists, really. It's just another data structure that behaves very similarly to arrays. I can't even really like the discussion we had about arrays versus lists isn't on the exam because it's not in the curriculum, right? That's bonus knowledge. So, yeah. Aside from that, we just have exception handling and generics. I've already said that generics won't be on the test. Generics are basically the idea of a type variable. When you declare an array list, there's one specific piece of Java syntax which is different from pretty much everything else we've used. Oh man, this thing's going, eh? Rip. It's this bit. When you see a type with angle braces after it, with another type inside of it, that is a generic. So, when we declare an array list, we declare it as an array list of something, right? It's a type, array list is a type, but it's a type that requires another type in order to compile. That's what a generic is. Generics are type variables. When you declare a class, you can do so and create your own generics. So you can do something like, public class, bag T, right? And then you can say, a bag is, it's an array of T's. T bag. The reason I wasn't actually intending to make a pun, like a bag is actually like, it's a thing in math, it's like kind of like, it's like an unordered collection of items that when you get something out of it, you pick it randomly. Like you had a big bag of marbles and you reached in and you pulled a marble out. Like that's, like it's a math thing, okay? But anyway, once you've declared the type variable for the class, you can use this as if it were a type, a declared type. But it's not. Basically, when this thing receives a parameter like this, T is substituted for whatever is provided. So if we declared this a bag of integers, this would be replaced with integer. If we declared it a bag of strings, this would be replaced with string. If we declared this a bag of bags, then a bag of bags of integers, we could do that, right? Because this is also recursive, right? Because the type that this can be is the same type that the class is. Make sense? Good. Same thing with array lists, by the way. If you want a two-dimensional array list, then you get, an array list of array lists of type integer. Like that. Now, you may wonder why I didn't say int here. I said integer. Generics receive class names, not primitives. In order to provide primitives here, you need to wrap them in classes. Fortunately, Java provides a wrapper class for pretty much, well, not even pretty much, for every single primitive type, from character all the way on down to Boolean. Make sense? Generics? Good. Final topic is exception handling. We're right on time too. So, exception handling is easy. The hardest bit about it is providing multiple catch statements. Actually, the hardest thing about using exception handling is correctly spelling the exception names. So, if you have an operation that may result in an exception, you throw that into a try block. Typical examples of things that might throw exceptions include anything to do with the user. Particularly, I'm thinking of reading like next int. If they don't give you an int, that's an exception. But also things like int x, x is equal to 5 divided by 0. That will also produce an exception, a 0 division exception. Hopefully Java is smart enough to be able to catch that because it's a literal, but if it isn't, then here we are. So, we then catch, and we catch exceptions of particular types. If we know that this is, for example, an array out of bounds exception E, then if an array out of bounds exception is triggered while we're in the try block, we stop that immediately, execute this block. The catch-all, so to speak, is exception itself. All exceptions in Java are subtypes of this bad boy. So this, it doesn't matter what kind of exception you get out here, it will match this and then execute it. So this is like your else case. Make sense? How do we create an exception?
Throw new exception.
Throw new exceptions. Throw new exception. You can throw new exceptions of pretty much like you just use the constructor for whatever type of exception you're intending to create. The sort of typical, like a lot of them are ones that you're not supposed to touch. You know, like there's really no reason why you you, a person who is not programming the Java compiler, should have any use for an arithmetic exception. You should never have to raise an arithmetic exception, right? Unless you're doing something extremely mathy that they didn't think about, which is unlikely, right? However, illegal argument exception, that's something that you will often see in user code, right? Because, you know, it's very probable that the method you've written will flop if you give it, you know, integers that aren't within a certain range, that sort of thing, right? Make sense? But the key word is raise. Raise, and then it expects an exception object. This is Java, so everything is object. How do we create a new object? With the new keyword. And you can even throw a message in here. Make sense? Any questions? Any questions from people? That was a little bit machine racist, but that's okay. Well, I'm fairly nobody feels like we forgot anything that I can talk about in the last 3 minutes? Do we feel this has been fairly comprehensive as a review goes? Good. Well, in that case, work hard. Don't spend all your mana on assignment 6 because you got exams coming up, right? Yeah, okay, get out of here. Go home.
Chris, I have a question for you. I wanna see how this, I wanna see